Hey algebra students, here are your 7-4 notes for transformations of exponential functions. So up until this point, you have been graphing exponential functions that are from the parent functions, and then when we stretch that out, we can see that the y-intercept is a, and because you can see that y-intercept, you've taken a step past your parent function. Today, we're going to take it another step forward. Okay, so thinking like your parent tells you you're going to buy a car, and then you can see the y-intercept, so now they bought your car. And in this section, now you're getting the keys to the car, and we're going to start moving all over the place. Okay, so a lot of vocabulary that we're going to hit, a lot of different words that we're going to have to remember, so making sure that when we are studying for this quiz, we might want to make some flashcards so that we know every piece to the puzzle. Okay, so zooming in to our vocabulary first, let's just reiterate what we know about exponential functions. Okay, remember that when we see the letter A in this equation, okay, ignoring these other two, you can see that A times B to the X has the parent function. A being the y-intercept, okay? One thing that is new here is that if A is negative, the graph is reflected over the x-axis. Okay, so it kind of flips, and we're going to be able to see that here in action in just a second. But over the x-axis, we reflect it if this number, your A, is a negative number. Okay? One thing that will happen is that when your A is greater than 1, you'll have a stretch. And then if your A is in between 0 and 1, which we now know can be a fraction, it's going to shrink. Okay? So these are two new words as well that we will be able to see in action down below. But when you're thinking about a stretch, know that when we're talking about an exponential function, if we take a look over here, we're moving faster than we are if we were linear. Now, imagine if I took 2 to the 4th and then multiplied it by an A that is, say, 6. We're going to be jumping up even higher. So 2 to the 4th times 6 is going to force our graph to kind of move and go like that, really quick, really fast. Okay? So because it moves faster, that's what we call a stretch. You're going to stretch because you're jumping up to hit those higher numbers a lot faster. When we have this A that is a fraction, we're looking like we're slowing down our graph. We don't really need to go up as fast. So we call that a shrink because we're not really moving faster. We're taking our time. We're really actually trying to slow down that graph when we have a shrink. So stretch, moving really fast, which is why A is going to be bigger than 1. And our shrink is less than 1 because we're moving slower when we have less than 1. We've already talked about our letter B. We know that that is our common ratio. So if you want to write that in just to refresh, we know that this is our common ratio. Okay. We know that if it's greater than 1, we have a growth. If it's in between, we have a decay. Not new information. That stays the same. Now, what changes here is when we have these two pieces of information. Okay, we're going to come back to this in just a second. What I really want to focus on right now is this A. What happens when we reflect? Okay, so we're going to go ahead and sketch a reflection over the x-axis. Now this goes back to your transformations. Okay, something you might have talked about back in pre-algebra. But if you're looking in the mirror, and you see your reflection, if you lift up your right arm in the mirror, it kind of looks like you're also reaching up your right arm, but it looks flipped. To you, it looks like it's on the left, right? So we're flipping over that line. We're flipping over that mirror to the other side. So if we take a look at this graph, if we were to flip all of our dots to the other number or to the other side of the x-axis, which is right here, okay, if we flip it over, notice that if I just take my first dot here and I flip that over, I'm now on this side of the x-axis. If I take my second dot, which is when x is 1, if I flip it over, I'm now here because I'm 2 away, so I got to be 2 away. If I'm going to come over here, I'm 1, 2, 3, 4 away. So I got to be 1, 2, 3, 4 away over here, just like you would a reflection on the other side. Okay. And if I take a look to my last point, I'm 1, 2, 3, 4, 5, 6, 7, 8 away. So on this side, I'm going to be 1, 2, 3, 4, 5, 6, 7, 8 away. Okay, and then this dot, we're not really sure what this point is, but if I just flip it to the other side, that's where our other dot would be. All right, so again, flipping to the other side of the x-axis as like our mirror. Okay, now if we take a look at our ordered pairs, on our red line, we have a y value of 8, we have a y value of 4, 2, and 1. But if we take a look, we have -1, -2, -4, and 8. -8, sorry. So if we pay attention to what happened, when we reflected, our equation changed from all positive numbers originally to now all negative numbers. So when we have a reflection, how do we change any number from the positive version of itself? Well, we just multiply it by a -1. Okay, so you might see it written like this. That -1 is showing that reflection. Okay, that -1 is showing the reflection. But there's a chance that you might see it written like this. Okay, so don't forget that when we write our equations, sometimes we can't see that letter A. Sometimes it looks like it's just the parent function, but there's technically that -1 in front of that 2 to the x. Okay, let's take a look again on this side. If we wanted to look at a decay, what would a reflection look like if we had a decay? Oh, and I'm sorry, I forgot to finish our graph on the growth. So knowing that it is a reflection, it's still a growth, it just got flipped to the other side. Okay, so now we have an exponential decay. Notice that we have our parent function. We want to reflect this line, so what we're going to do is we're going to flip it over the x-axis. Okay, so I'm going to go ahead. I'm 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. So I got to be 8 this way. So I'm here. 4 here. 2 here. 1 away here. And then about a half away there. Okay, again, looking at just our y values. 8, +4, +2, +1. And now look, I'm at -1, -2, -4, -8. So again, seeing that all of our y values that were once positive are now negative. So when we write that reflection, it reflects because everything is multiplied by a -1. That's how we change those numbers. And again, you can see it two separate ways. You can see it separated with that -1, or we can squish it together because remember, sometimes our 1 can be invisible. All right, but a reflection just means that we took everything and multiplied it by a -1. Okay, so that's what can happen to our A. So be careful. Look for that negative to determine whether you have a reflection, which is a transformation. Okay, now what we're going to do is we are really going to come down here and look at the H and the K. So we have an H, which is our horizontal shift. That means we are moving left or right. Now we've seen these letters before. We've talked about them. We've done them before. Remember that H lies. It's a liar. It's going to look like it wants to tell you the correct place. But when we see a plus sign, that really means left. When we see a minus sign, that really means we're going to the right. Okay? And then last but not least, we have a vertical shift, which we show with the letter K. Again, we've talked about these before. I'm trying to think of what section we talked about them in. It'll come to me in just a second. But we've talked about these shifts. K means up or down, and K will always tell the truth. Okay? It's never going to lie to you. All right? It's never, ever going to lie to you. So let's go ahead and get started. Jumping down, let's talk about what these transformations, when we see them all in the same place. Okay? Remember that when we have an A, if it is greater than 1, that means we're going to have a stretch. It stretches the parent function. It's reaching up faster. It's getting bigger faster. When we have our H, okay, that is going to be right here. All right? So if I take a look, notice that the H and the H is in the exponent and the K is on the outside. All right? So your H is on the exponent and the K is on the outside. So here, our H is -3, but because it's negative, we know that it lies. So when I see a -3, that really tells me that I have a +3. Okay? So that means that we shift to the parent function to the right by 3. We move it 3 times to the right. And then K tells the truth. When you see a +6, we're actually going to go ahead. Positive means up. We're going to move in a positive direction. Okay? Looking at our next transformation example, when we have the A that is negative, okay, I see it. Do you guys see it? That -A. That means we're going to have a reflection. That's super important. So we've got a lot going on. A is less than 1, which means we are shrinking that parent function. So be extra careful when you see that we're shrinking that parent function. That's just the half. The negative belongs to the reflection because there's technically a -1 here. Okay? The H, remember, it lies. So when I see a +3, that really means that I have a -3. So instead of going to the right 3, I should be going to the left 3. And then last but not least, you have your H. And it is what it is. So when you see that, you're going down 6 because it shows you a -6. All right, so now we're going to go ahead and we are going to move on and talk about what all this actually looks like and identify these for ourselves. Okay, so jumping down, going back, oh, almost dropped my iPad. Going back down, knowing all of these different parts, we're going to take our time to talk through these. I'm going to go ahead and bring that exponential function equation down. Y equals A times B to the X minus H plus K. So notice that the minus sign belongs to the formula, which is why our H is a liar. Okay? The minus sign belongs to the formula. So let's go ahead and dive in. Looking at number 1, we have y equals 2 to the thirds times 6x plus 1. When we're looking at a growth or decay, we are looking for a specific letter, and that's going to be our B. When we're looking at the B, in this case is a 6. So because that is greater than 1, we're going to have a growth. Looking at stretch or shrink, when we're determining whether we have a stretch or shrink, we're looking at the letter A, which in this case is 2/3. So because we have a number that is less than 1, we're going to take our time. And because we're taking our time, we are trying to shrink this number. We're trying to make it smaller by having that fraction. Looking at whether we have a reflection, well, we're looking for that letter right in front. We're still looking at the letter A. And there is no negative. So because there's no negative symbol, we have no reflection. Okay, looking at our shifts, this is going to be the H and the K. So when we're looking at the up and down, we're technically looking at the letter K. Now, notice that the k would be here. So because there is no k here, we do not have an up and down shift. So we can cross that out because we don't have it. So we don't need to see it. But what we do have is an h. Now again, notice h, I'm not highlighting the minus sign because the minus sign belongs to the formula. So in order to get a positive 1 here, because it's x minus h, what we had to throw in was h equals -1. We had to throw in a -1. Remember, it lies. So because I see a positive 1, I want the opposite of that. And h talks about left to right. So because we're negative, we're going to the left. Just like we would on a number line, we're going to the left. And we're going to the left 1 time or 1 unit. Looking at number 2. Again, keeping all of our pieces of information, talking about them here. Okay, so A, oh, I have that backwards. B, A, K. Okay, so now let's go ahead and talk about growth or decay. When we're talking about growth or decay, we're looking at the letter B. So here's our B. We've got 2/3. Because it's 2/3, it's smaller than 1. We have a decay. When we're talking about a stretch or a shrink, we're looking at the letter A. Right here, we have the number 4. So because it's greater than 1, we're stretching up. We're going up super fast. We're making these numbers bigger, faster. So we're stretching to get to the top number ASAP. It's kind of like reaching for the top shelf. You want to get there faster, so you have to stretch. Is this reflected? So we're looking for that negative. I see that negative. There's technically that -1 out here. So because we have that negative, yes, that A is reflected. So this graph is reflected. If we're looking for up and down, we're looking for the letter K. So notice that we do have a K this time. Remember, K tells the truth. So K is -3, which means we're going down 3 units because negative means down. And then last but not least, we have our H, which means we're talking left to right. So right here, the negative sign belongs to the formula. And because it belongs to the formula, the H really is a +1. So that means we went to the right because we're positive 1 unit. Looking at number 3, again, just going through all of our paces. When we're looking for growth or decay, we're looking at the letter A, and in this case, I see it right here at the number 3. Because it's greater than 1, we have a growth. Looking for our letter A, now if we notice, I can't really see my A. So if I can't see my A, let's write it out to see if there actually is one. And you guys know that there always is going to be one. So I can rewrite this as y equals -1 times 3 to the x plus 2 plus 1. So rewriting everything, we can always see that A. So now what I can do is I can actually see whether we have a stretch or shrink. And because it is 1, okay, we're not really going to have a stretch or shrink. We're not changing this number at all. So we're not going to stretch and we're not going to shrink, okay? We're not making this number any bigger. But what we did do is we reflected because we made that 1 a -1. So notice that you have that negative right there, but we did not have a stretch or a shrink here because 1 doesn't do anything to our numbers. Then we have our up and down, which is our K. So if we take a look, our last number in both of them was a +1, and we can take that for what it is. So we're going up 1. And then last but not least, we have our K. What I see is a +2, but remember, it lies to me. So my H, in order to make it a positive, I had to minus a -2. Okay, so don't forget that that minus sign belongs to the formula. So because it's -2, that means I went to the left 2 units. All right? Lots of pieces of information in order to remember what you've got going on an exponential function. okay? And here's just a picture of everything that we just talked about. Might be what you put on a flashcard situation here. This is super important for you to know all of these different pieces, okay? Don't forget that f of x just means y. When we go think back to what we talked about in function notations, f of x is just y equals, they're the same exact thing, okay? All right, moving on. How does g of x compare to f of x? So now just looking at the equations, what kind of transformations do we have? So if we look, the only thing that's different is these numbers in our exponent. And so because it's in our exponents, what we're really talking about is our h's. So for the first equation, we have h equals, and because I see a positive 1, what we really have is a negative 1. And in my second equation, or function, I have h as negative 4, because again, it's positive, and our h lies. So we're always taking out the opposite. Okay, before we answer anything else, let's identify the parent function. So where did this graph start? Well, this graph started, both of them started at 6 to the x. So that's our parent function. Remember, it's just b to the x. So going back to our h's, how did f of x go to g of x? Well, how did negative 1 go to negative 4? Well, in order to do that, we had to minus 3. So because we minus 3, that really means that I went left 3. Because we went from negative 3 to get here. So that means left 3. Jumping down to number 2. Again, let's identify that parent function first. So that parent function is just y equals b to the x. That's what our parent function is. So now let's go ahead and identify that. If I have f of x equals 2/3 to the x minus blah, 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 I already have my parent function. Y equals 2/3 to the x. Okay, so now what we're going to do is we're going to talk about these transitions. So let's go ahead and start with our h's. If we have our h in our first function, we identify it as negative 1. Even though it says negative 1, it's a liar. So because it says negative 1, I write positive 1. When we're talking about the g of x, I have a negative 1 again. So that really means that I just have a 1. So how did I go from 1 to 1? Well, we didn't do anything. We didn't add 0. We didn't subtract anything. So because nothing changed, we would say there was no horizontal shift. We wouldn't go left or right at all. So we just wouldn't write anything down. We wouldn't say the transformation happened. Okay? But notice that this time we both have k's. So if k tells the truth, then this is negative 3. And in our second one, k is 4. So the question is, how did you go from negative 3 to a positive 4? Well, we had to add 7. So because we are adding 7, that means we're going up, up, up our y-axis. So we really went up 7. Our graph moved from f of x to g of x. Up 7. Number 3. We have f of x equals 3 of x plus 2 plus 1, and g of x equals negative 3 to the x minus 4. Again, our parent function is y times y equals, b to the x. So we need to identify that first. So for both of these, notice that we have 3 to the x both times. So it's y equals 3 to the x. Okay, now we always have to identify everything that changes from one to the other. And one big thing that I notice is that on g of x, it went from a positive 3 to a negative 3. So because we have that negative a in g of x, we know that this graph was reflected. It flipped over the x-axis. Now going up to our h's, I noticed that f of x has an h of a positive 2, so that means it really is negative 2 because it lies to us. So that means when h of 0 in the second one, so how did you go from negative 2 to 0? Well, what we had to do was add 2. So because we added 2, we're going to the right 2. We shifted to the right 2 from a positive 2 to a 0. Because positive means to go to the right. And then last but not least, we have our k. So positive 1, negative 4. K is 1. And k is negative 4. How do you go from a 1 to a negative 4? That's our question, 1 to negative 4. Well, we had to go, we're getting negative, so we have to go left, right? We have to go left, and we're going to the left 5 times to get there. Okay, because we started at a positive 1 and moved to the left. Or I'm sorry, not left. We're talking about k, so this should be down. We went down 5. Whoops, almost got confused. All right, you guys, stay with me. 3 more. Now we're going to look at it, what it would do on a graph. And this one's a little bit easier because we can literally see what's happening. So we did the hard stuff first. Let's go see what happens when we actually have a picture this time. Okay, so when we're looking at our graph, when we're talking about the growth or decay, we're always going to talk about that parent function first, that first one. So the f of x is showing that we have a decay because it looks like it's going down. You look like you're going down a slide. Then we want a transformation. And so the only thing we can see right now is that we're going from red to blue. Okay, so how do you go from red to blue? Well, each dot, let's pay attention to what happens to each dot. So we're started here. Now I'm going 1, 2, 3, 4 down. But I'm going to double check that all of them do that. So starting at f of x and going to g of x, I went 1, 2, 3, 4 down. So the only transformation that we have going on is that we went down 5. From red, or sorry, oh my goodness, down 4. From red to blue. Number 5, notice that both of these look like they're going up in a growth formation. So looking at f of x, we had a growth first. Okay? We're just going to check from each dot. So how did I go from this dot to this dot? Well, I went down 2, and it's kind of going to remind us of slope. So I went down 2, and to the right, 1, 2, 3. Okay, but we're going to double check every single one. So we're going down 2, and to the right, 3. And those are my only 2 dots. So I went down 2, and to the right, 3. Last but not least, this is the last one we're going to do today before you turn in your notes. Okay? So, first of all, we're going from f of x to g of x. So, it started off as a growth. Okay? And it still is a growth because it's always about where it starts. So, we have a growth, but immediately we can see that this was reflected. It looks like it got flipped over. Okay? So what we need to go in and do is, because it's moved past its reflection, we need to go in and draw that reflection before we can see how many we've shifted. Okay? So I'm going to go ahead and with my orange pen, I'm going to draw each dot the same distance away on either side of the x. So my first dot is only 1 away from the x-axis. My second dot is 3 away. So that is my reflected line. Okay, if I were to draw this parabola this is what it, or no, sorry, exponential function. That's what it would look like reflected. But right now I don't care about that graph being reflected. What I care about is what else it did after that. So now we can count from our orange dot to our blue line. We went down 2, and I didn't go to the right or left anywhere. So I'm going to check my other dot. It also went down 2. So because it went down 2, that is the only reflection and shift we have. Okay? So when you have a reflection, you have to find the original, flip, and then see if it moved from there. And we'll talk more about that when we get to the second part of these notes, when we get into graphing and talking about all these different parts. Okay, that is the first part of your 7.4 notes. Go ahead and submit and start making those flashcards so that you know that vocabulary.